The Persian Gulf at night is not dark in the way that open ocean is dark. It carries its own ambient luminosity, the gas flares of the offshore oil platforms to the north and west, burning continuously at the tops of their derricks in columns of orange-yellow light that reflect off the surface of the water and paint the low cloud cover with a diffuse industrial glow that never fully disappears. The tanker traffic moves through this light in slow procession, their navigation lights strung like distant constellations across the surface of a body of water that handles more petroleum in a single week than most regions of the world process in a year. It is a busy sea, a well-lit sea, a sea that has been commercially important for so long that its operational rhythms have become predictable in ways that anyone who studies them carefully enough can learn to exploit. The destroyer had been on Gulf patrol for 22 days. Its assigned sector covered the central Persian Gulf approaches, the shipping lanes used by tankers transiting from the upper Gulf terminals toward the Strait of Hormuz, and the patrol had been characterized by the specific kind of operational tension that defines extended presence in a contested maritime environment. Not the acute tension of an engagement, but the chronic tension of sustained alertness in a space where the threat is real. The adversary is continuously present, and the indicators of imminent action are never entirely absent. The crew had responded to 14 separate alert situations in 22 days. None had escalated to engagement. Each one had required the full activation of the ship's combat readiness posture, the cycling of weapons systems to engagement-ready status, and the subsequent stand-down when the alert resolved as something other than an actual attack. 14 activations and 14 stand-downs. The cognitive and physical cost of that cycle, repeated across 3 weeks, was not zero. The intelligence picture in the 72 hours preceding this particular night had been elevated in specific ways. The IRGCN small boat activity in the upper Gulf, the zone of shallow water and coastal island chains that the Revolutionary Guard Navy uses as its primary operating environment for small unit maritime operations, had increased measurably. Signals intelligence had captured coordination traffic between IRGCN coastal command elements and what appeared to be forward-deployed maritime surface units, though the content of the traffic was encrypted and the positional data was imprecise enough to prevent confident targeting. The pattern was consistent with preparation for a maritime operation of some kind. It was not, by itself, actionable intelligence. The Gulf produced this pattern regularly, and only a fraction of elevated preparation cycles ever translated into executed attacks. What the intelligence picture had not specifically flagged, because the capability it represented had not been previously observed in an operational context in the Persian Gulf, was the possibility of surface drone employment. North Korean and Iranian technical cooperation in the unmanned systems domain had been assessed by the intelligence community for years. The specific application of that cooperation to maritime surface platforms, remote-controlled or semi-autonomous surface vessels capable of operating as one-way attack systems against naval targets, was a known concern, documented in threat assessments, discussed in operational planning documents, included in the training syllabus for naval surface warfare officers at the postgraduate level. It was known as a theoretical threat, what the crew of the destroyer had not encountered in 22 days of Gulf patrol, and what their pattern recognition had not been calibrated by recent operational experience to detect, was what a surface drone attack actually looked like on their specific radar systems in the specific acoustic and electromagnetic environment of the central Persian Gulf at night. At 1:33 a.m., the surface search radar picture showed what it almost always showed in the central Gulf at night: a dense, overlapping mosaic of small surface returns at ranges between 3 and 18 nautical miles, distributed across the sector, in patterns consistent with the fishing vessel traffic that operates in the Gulf continuously, day and night, in vessels ranging from small wooden-hulled dhows to slightly larger fiberglass-hulled craft, whose radar cross-sections occupy exactly the same portion of the signal return spectrum as a low-profile surface drone moving at low speed. The fishing vessel traffic was the camouflage. It had been chosen deliberately by planners who understood that the most sophisticated radar system in the U.S. Navy's surface warfare inventory would have difficulty discriminating between a slow-moving, low freeboard, wooden fishing boat with a small radar cross-section, and a slow-moving, low freeboard, unmanned surface vessel with a comparable radar cross-section. In an environment where fishing vessels are the background noise against which every other surface contact is measured, the surface drone formation had been staged from a coastal inlet on the Iranian side of the Gulf, deployed in groups over a period of approximately 3 hours before the engagement to avoid the contact density increase that a simultaneous mass launch would produce on the surface radar picture. Each individual drone had been programmed with a transit route that took it through the existing fishing vessel traffic patterns, moving at speeds between 8 and 12 knots, the same speed range that working fishing vessels maintain during their night operations, and maintaining heading variations that approximated the wandering course behavior of vessels under fishing operations, rather than the direct, consistent heading of a platform, transiting to a specific objective. By 1:33 a.m., 26 surface drones were distributed across the surface radar picture within 18 nautical miles of the destroyer, indistinguishable on the radar display from the fishing vessels among which they had positioned themselves. They had been in position, some of them, for more than 2 hours, waiting. At 1:33 a.m. and 44 seconds, 26 surface returns on the radar picture simultaneously changed their behavior. The change was not subtle in retrospect, but in the moment, in the first 2 seconds after it began, it was ambiguous enough that the watch team's trained pattern recognition processed it as a radar anomaly rather than a coordinated tactical behavior. What happened was this: 26 contacts that had been maintaining the wandering, variable speed profiles consistent with fishing vessel operations abruptly resolved onto direct approach bearings toward the destroyer's position, and simultaneously increased speed to between 22 and 28 knots. The speed increase was the tell. Working fishing vessels in the Persian Gulf do not accelerate to 25 knots at 1:33 a.m. Nothing that moves at 25 knots on the surface of the Persian Gulf in that contact density at that hour is a fishing vessel. The surface warfare officer on watch had the recognition and the call out of his mouth in approximately 4 seconds from the behavioral change. Multiple surface contacts, coordinated acceleration, direct approach bearings, all hands combat stations. The TAO was in the CIC within 90 seconds of the alert. Not because he had been sleeping, but because he had been in his sea cabin adjacent to the CIC running through the watch turnover documentation when the alert came, and the 90 seconds represented the time it took him to move from his chair to his console and absorb the threat picture that had already been updated twice by the time he sat down. What he saw on the display when he arrived was a surface contact picture unlike anything in his operational experience. 26 contacts, all accelerating, all on direct approach bearings, distributed across a 340-degree arc around the ship, not from a single direction, not from 2 directions, from essentially every direction simultaneously, with only a narrow sector to the southwest. Where the tanker traffic corridor was densest and the drone operators had apparently assessed a higher risk of collision with commercial traffic, that was not represented in the approach arc. 340 degrees of simultaneous surface threat. The geometry was not designed to create a single point of hull impact. It was designed to require the ship's defensive systems to cover a full spherical threat arc simultaneously, to force the CIWS mounts, the deck-mounted weapons, and the ship's crew-served weapons to engage contacts approaching from every compass point at once, accepting that the coverage gaps between weapon systems on a vessel designed for forward arc engagement would create sectors where contacts could close to very short range before a weapon system could be brought to bear. The TAO made his first call before he had finished processing the full geometry of the threat picture, because the geometry of the threat picture was already informing him that he did not have the time a complete assessment would require. All CIWS to automatic engagement mode, full arc coverage. 25mm deck mounts to manual engagement, crew-served weapons to all stations, maximum rate of fire authorization. He then called the commanding officer, who had been in his sea cabin, and arrived in the CIC 40 seconds after the TAO. 40 seconds during which the closest contacts had closed from 11 nautical miles to approximately 9.4 nautical miles. The CIWS automatic engagement mode has a surface engagement capability that is operationally distinct from its primary anti-aircraft mission. Against surface targets moving at 25 knots, the engagement range is constrained by the weapon's depression angle, limits, and the radar discrimination challenges of engaging low freeboard targets on a sea surface that generates its own radar returns. The effective surface engagement range in these conditions was approximately 1.8 nautical miles, not the multi-mile engagement range available against aerial targets, but enough to provide a meaningful terminal defense layer if the contacts could be detected and discriminated from background sea return in time to build an engagement solution. The 25mm deck mounts and the crew-served .50 caliber systems were faster in their engagement capability against surface targets at closer ranges. Their direct fire, visually aimed engagement mode bypassed the radar discrimination problem by substituting optical target acquisition for radar-based targeting. In the ambient light of the gas flare glow and the ship's own deck lighting, surface contacts at ranges inside 1 mile were visually detectable against the water surface. The limitation was rate. With contacts approaching from 340 degrees, 4 crew-served weapon stations could not simultaneously cover the full threat arc, and the crew's physical positioning, even at maximum combat station density, left sectors of the approach arc where contacts could close to very short range before a crew-served weapon could be repositioned to engage them. The IRGCN planners had understood this. The geometry of the attack was designed around it. At 1:36 a.m., the closest contacts were at 4 nautical miles. The commanding officer and the TAO, looking at the same display, were making the same calculation simultaneously. The ship did not have the organic surface engagement capability to intercept 26 surface contacts, approaching simultaneously from 340 degrees. The CIWS could cover the sectors within its engagement arc with lethal effect. The 25mm mounts could contribute significantly on their assigned arcs. The crew-served weapons would engage whatever they could reach, but 26 contacts, distributed across nearly the full compass, closing at 25 knots, were going to present more simultaneous engagement requirements than the ship's surface defense systems could fully service before some contacts reached very close range. The commanding officer transmitted the emergency contact report to the 5th Fleet Command Element and requested immediate air support. The response time from the nearest available aviation asset, a naval helicopter operating from a forward-deployed platform 40 nautical miles to the northwest, was approximately 14 minutes. 14 minutes was longer than the engagement that was currently developing. The CIWS forward mount acquired its first surface contact at 1.9 nautical miles bearing 023 degrees and opened fire at 1:37 a.m. The rotary cannon's engagement against a surface target produces a compressed burst, not the extended aerial engagement sequence, but a shorter, more concentrated burst aimed at the contact's waterline, where the projectile impacts are most likely to achieve the kind of structural compromise that stops a moving surface platform. The first contact's surface return scattered and then disappeared, the radar losing the contact's discrete return as the hull integrity was compromised and the target took on water, its radar profile collapsing into the sea surface return that surrounded it. Contact eliminated, bearing 023. The mount pivoted immediately to its next cued target. The aft CIWS mount was simultaneously engaged on the stern arc, where 3 contacts were approaching in a loose cluster on bearings between 157 and 189 degrees. The first 2 were engaged in rapid succession at ranges of 1.7 and 1.4 miles. The third contact in the cluster had been using the other 2 as radar shadow, maintaining a position directly behind the lead contact that placed it in the radar reflection of the leading platform and reduced its own discrete return to a level that the CIWS tracking system had been processing as a single extended contact, rather than 2 separate targets. The third contact emerged from behind the wreckage of the second at a range of 900 meters and continued inbound. The aft CIWS mount reacquired. The target was smaller than typical, its surface profile lower in the water than the contacts that had preceded it, its radar return almost at the noise floor of the surface return environment. The tracking system's discrimination algorithm required an additional processing cycle to confirm a discrete contact lock against the sea surface clutter. That processing cycle took 1.1 seconds. At 700 meters, the aft mount opened fire. The burst connected. The contact disintegrated at 630 meters from the ship's stern, its hull breaking apart under the impact of the tungsten projectile stream, the wreckage scattering across the water surface in a debris pattern that the wake turbulence dispersed within seconds. The fragments that reached the stern did not penetrate the hull. The structural steel of the stern sections absorbed the low-velocity composite debris without consequence, but the physical concussion of the disintegration at that range was felt inside the ship as a sharp, distinct report transmitted through the hull, registering in the engineering spaces below the waterline as a sound that the watchstanders there had no immediate way to categorize. While the CIWS mounts were working their assigned arcs, the 25mm deck mount teams and crew-served weapon stations were engaging contacts in their sectors with direct fire. The port 25mm mount engaged two contacts approaching on the port beam arc between bearings 260 and 290, stopping both before they reached 600 meters. The starboard crew-serve station, a manually operated weapon requiring its two-person crew to physically traverse the mount and acquire targets optically, engaged one contact visually at approximately 400 meters, the operator identifying the low profile of the surface drone against the gas flare glow in the western sky, and placing sustained fire into the contact's hull until it lost headway and began to take on water. 400 meters. The crew-served operator would describe it later in the post-engagement debrief as being close enough to see the wake the contact was generating, a bright white line of disturbed water against the dark surface, very clear in the ambient light, moving directly toward the ship until the fire stopped it. At 1:39 a.m., the helicopter asset from the northwest checked in on the tactical frequency and began its approach to the engagement area. By that time, the engagement had been ongoing for approximately 6 minutes at close range, and the contact count had been reduced from 26 to 11. 15 contacts eliminated by the CIWS mounts, the 25mm mount, and the crew-served systems working simultaneously across the full threat arc. 11 contacts remained, at ranges between 2 nautical miles and 400 meters, the closest ones now inside the crew-served weapon engagement range and approaching the CIWS mount's inner engagement boundary. The helicopter's arrival changed the geometry of the engagement fundamentally. The MH-60 carried door-mounted weapons, and its aircrew could visually acquire surface contacts in the ambient Gulf light from altitude, engaging them with direct fire from above the contact's defensive arc, a firing angle that surface platforms could not replicate and that the drones had no programmed countermeasure for. The helicopter began its engagement runs at 1:41 a.m., working through the outer ring of remaining contacts at ranges where the surface ship systems were still operating at close quarters against the innermost threats. 4 contacts eliminated by the helicopter in the first 4 minutes of its engagement. 3 contacts eliminated by the CIWS and deck weapon systems during the same interval. 4 contacts remaining. 2 of the 4 remaining contacts reached the CIWS inner engagement boundary simultaneously. 1 on the port bow at 340 meters. 1 on the starboard quarter at 290 meters. Both mounts engaged at their respective contacts. Both contacts were stopped within 15 meters of each other in time, at ranges that put the disintegration debris in contact with the ship's hull above the waterline. Portside. 4 composite hull fragment impacts on the weather deck railing and 1 impact on the base of the port CIWS mount's radar housing. The mount's radar housing sustained a dent visible to the naked eye, but no penetration of the sensor array itself. Operational integrity confirmed. Starboard quarter. Debris from the contact's disintegration struck the starboard bridge wing windscreen and the upper portion of the superstructure below the mast base. The windscreen cracked across its full width. 1 fragment penetrated the windscreen and impacted the interior forward surface of the bridge wing enclosure, where it lodged in the steel at a depth consistent with a spent projectile rather than a penetrating round. No personnel were in the bridge wing at the time of impact. The standing orders for combat station configuration placed bridge wing personnel inside the bridge structure when surface engagement was ongoing. The helicopter eliminated the final 2 contacts at ranges of approximately 600 meters from the ship's hull, its crew using night vision equipment to acquire and track the contact's wakes against the dark water. At 1:44 a.m., the surface radar picture was clear. 11 minutes and 16 seconds from the simultaneous behavioral change that had identified the drone formation to the elimination of the final contact. 26 surface drones. 26 contacts eliminated across helicopter, CIWS, 25mm deck mount, and crew-served weapon engagements. 0 hull penetrations below the waterline. 0 flooding. 0 personnel casualties. Minor structural impacts to the weather deck railing, the port CIWS radar housing, and the starboard bridge wing windscreen. The weapons and ammunition expenditure summary was different in character from a missile-heavy engagement. No SM-2 or SM-6 interceptors had been used, because the surface drone threat did not require surface-to-air missiles, and because committing VLS inventory to surface targets would have left the ship without the air defense depth it needed to respond to any simultaneous or follow-on aerial threat. What had been expended was gun ammunition, approximately 6,000 rounds of 20mm through both CIWS mounts, 1,200 rounds of 25mm through the deck mount, and several thousand rounds of .50 caliber through the crew-served stations. The total cost of the defensive ammunition expenditure, approximately $240,000. The estimated cost of 26 surface drones, based on intelligence community assessments of Iranian domestic unmanned surface vehicle production unit costs, between $300,000 and $800,000 for the complete package, including staging, coordination, and electronic warfare support. Approximately $1.2 million. The ratio was not what asymmetric warfare usually produced. This was closer to financial parity than any engagement the Fifth Fleet Command element had seen in the preceding year of Iranian proxy operations. The surface drone attack, if it had been able to sustain its approach geometry without the CIWS intervention, would have been a low-cost, high-damage event for which the ship had no magazine-deep response. The engagement had been won by the CIWS and direct-fire weapons, systems with essentially unlimited effective ammunition capacity relative to the duration of the engagement, rather than by the costly interceptor inventory that air and missile threats required. But the post-engagement analysis surfaced a concern more troubling than the cost ratio. The surface drone tactic had worked in a specific and important sense. It had gotten contacts to 630 meters from the hull before elimination. It had produced debris impacts from 340 degrees of approach arc simultaneously. The tactical architecture had identified the specific weakness of a destroyer's surface defense geometry, the mismatch between the weapon coverage arcs available and the full circle threat arc that an all-aspect surface attack creates, and had exploited it directly. The tactic had failed this time because the CIWS engagement rate and the helicopter's arrival had been sufficient. Against a larger formation, or without helicopter support, the calculation might have been different. The IRGCN had found the gap. The drones had reached it. Losing the engagement had not cost them the intelligence value of executing it. The surface radar picture returned to its normal density of small contacts, fishing vessels, the ambient maritime traffic of a sea that never sleeps, indistinguishable again from what they were, and from what, on this night, they had been. The watch continued, because the alternative to holding the watch is allowing what the dark hours of this morning had revealed to become the permanent condition of the water, and the crew who held the line would not accept that without a fight.